So we're going to start the lightning talks in probably another 10 minutes or so. Just let everyone know.
So what's the website? I know. It's
Good. I'm going to grab some stuff behind you. You don't need to move.
Start here in a few minutes. Meerkat.
Oh, that's your. Oh, that's
All
hilarious.
right, so don't stand between the.
I'm going to be on the over on by the pool table.
All right. Well, yeah, I know. So I'm just saying is if you look how this is cropped here, you want to stand behind the computer there, and this way you're not blocking the screen.
Right. I'm not going to have anything up on the screen.
Yeah. Well, I'm just saying is so I'm just trying to get my speakers where. Let me see if this works.
Yeah. That's all right.
The camera's in front of the screen. I want to get the screen here, so what we need to do is put this on the side. So now you're here in front of the computer. Does that look good?
Yeah.
You can wait. It's like 6 to 8.
All right, so if anyone has anything like plugs or things they want to announce, short things, let me know. We're going to get started here in another minute or so.
I got 3 people.
Okay, we're going to get started. So, hello everyone, welcome to the HackerDojo Lightning Talk. Loud enough? Testing? What? Is that better? Okay. Hello, welcome to the HackerDojo Lightning Talks. We're going to get started here. Okay, so our first speaker is going to be Michael Chung, and he's going to present SolarSETI, or SolarSET, which is an inflatable solar concentrator that we did a grant application for NASA. And okay, I'll let him come and present.
Oh, the mic, Michael. Okay.
Hi guys, thank you. to the hundreds of people in the audience and about 2 million watching on Periscope. Thank you very much. Anyway, a couple guys, at HackerDojo, we came up with an idea related to using a balloon shape for concentrating solar rays, and we thought it could be useful, for instance, like in satellites, and it's an alternative to rigid solar arrays. So the idea is a balloon shape reflector, which has, let's say, the top half is transparent to let the light through. The inner bottom will be reflected to reflect the light back up to a photovoltaic collector. So one use case that we focused on is for like small CubeSats. They're small. They're typically maybe about 2-3 inches wide and about 8 inches, 9 inches long. And so the CubeSats, that's the shape there. And they typically have this rigid array. And we thought we can mount additional solar power alternative to the bottom of these CubeSat. So over here, you can have the solar rays coming in, it'll bounce off and be collected under the satellite. And this is another way to angle the balloon inflatable shape if you want to have the satellite at a different angle. And this will be our container. This will be in the housed in one of these units, like 2.5-inch cube, and basically this is the gas container. And when in low orbit or when it's in space, basically the gas will release and automatically release the inflate and deploy the balloon. So this could be one configuration where you have the power and the test unit in here, and we could mount this module right here. Okay. So we were thinking about some other type of uses, and then we found out about Google Loon with their high altitude balloons that goes up about 10 miles, and they're using right now, their configuration is, they're getting the power from hydrogen fuel cells and solar array. Their solar array looks like this. It's a rigid array, and this thing outputs about 100 watts. So we thought that possibly you could mount a balloon shape inside the balloon, a transparent balloon, and it can generate additional power, possibly 10, 20, 30x of what they're getting now, and much more. So the other uses are that you could have, it's basically a very small package, right? You can put it in camping, or you can go camping with it, or it could be a survival kit, and it's very cheap, it's disposable, and when it deploys, somehow you blow it up, it'll deploy maybe into about 1 meter, 2 meter diameter reflector with a concentrator. And we think it can generate maybe 300 or 500 watts. So basically, we formed a team and we're just exploring it. We're doing some mathematics and just going through the figures, still in the ideation stage. So, yeah, that's it. Thank you. Any comments?
All right, so while Paul's setting up, we're on top, and Rick, if you want to come and do a brief announcement here about what you've got going on.
Okay, so I'll see if I can do real fast show and tell. I'm working with a couple of groups that have regular meetings at the dojo. One of them is, I don't know if you can see this is the Silicon Valley Space Center. Nowadays, it would be svsc.org is where you would find it. And we've been meeting actually at the dojo since the first building back in 2010. We brought out what ultimately became Planet Labs. We actually even had Planet Labs come back and talk over here. So we've been looking at, you know, who's been on kind of the cutting edge, or who's been willing to do these small payloads, like what this type of thing would be able to enable, and how do we bring down the cost of our, you know, spacecraft development, things of that sort. So the other group I've been working with has been the Experimental Rocket Propulsion Society, which has been in the Bay Area since 1995. And they did a launch of a small rocket, hydrogen peroxide, liquid hydrogen peroxide plus kerosene back around 2003, something like that. And they're getting ready to do another launch. And so we've been meeting here on a monthly basis. So I sometimes talk about these things on, there is a Slack channel that says pound rocket dash science. And you'll sometimes find me in there. I'm the guy that instigated all that. And I guess that's it. If you want more information, come find me later.
All right, so this is a moment to thank Zumi Pizza, which is a robot-made pizza, and they're giving us a very good deal on this pizza. They presented last week, and okay, our next speaker is Paul, and he's with SAKE Robotics, and he's going to be showing us his low-cost robotic gripper.
Hi again, my name is Paul Ikas, SAKE Robotics. Alright, so I'm going to have to go. So the challenge in robotics, besides making a robot do something useful, which a lot of people are working hard on, is low-cost hardware. I took on a challenge of making low-cost grippers a couple of years ago and just reaching production units. I'm going to demonstrate those for you, tell you some of the attributes of those, but they, in my opinion, I have to have that, are revolutionary for the cost structure of robotics. So this is one of the first 100 production units. That's called a quad. Has 4 fingers associated with it. The key characteristics of this is it's designed to pick stuff up and put it down. This is not a high dexterity, but it's for the high volume applications or in-home applications for manipulating objects to pick them up and put them down. This is what's called a quad. That's actually 2 duals. I'm going to demonstrate to you a dual, and this goes on the end of a robot arm. So if you have a robot that has a hand on the end, that's what this is. So how do you demonstrate a robot hand without an arm? You put it on a drill. And it works very well at trade shows. So that opens and closes. This has full control of position, full control of torque. So I'm going to just do some different demonstrations. I'm going to do them here at the end of the table. I'm going to do some ones that are fairly new for me to demonstrate and are challenging. Nobody here has seen this one before. Some of you may have seen me demonstrate earlier versions. This is the latest. So, picking up a pen. See if I have a pen. I should have a pen. So, robot has to come in. Picks it up. Got a secure grasp of it. Won't let it go. It can pick up a fairly large bottle of water. It's actually got a softer grip than we do because it distributes it better. It's an interesting thing. I can't pick up these things without squeezing it fairly hard, and some of these things I can't pick up with a hand the way it can at all. And this one's just an impressive one. It's almost 4 kilograms. It's a gallon. And if you think of a robot hand working at your house, helping you in getting a gallon of milk out of the refrigerator, it needs to be able to do something like that. This is a dual. This is half of a quad. A quad adds stability and doubles the power of what it can grasp. It can grasp all different types of objects, but I wanted to do some strength ones here for you because people are concerned about strength and durability. I'll tell you a little about that, but I'm going to show you it lifting 25 pounds and then 25 pounds on a single finger. This is a NIST compliant new grip strategy that they have. And they have 3 different tube sizes that they're using, so I'm using one of the NIST tube sizes. I have some well-used weights. Actually, not well-used. They're in the garage the way everybody else's weights are. Robot's getting stronger. That's 25 pounds. So a little over 10 kilograms on a single grip. All right, so this one takes all my strength. That's on a single finger.
I don't know if everyone can appreciate how advanced that is to be able to do that in single lift, which is good.
Not breakable. Robots are hard to control. They hit things and break. These are called breakaway fingers. So that robot gripper is the dual. This is a quad. These are the lowest cost grippers in the market. They have the highest width in the market. They're the lightest weight in the market. They're human safe. They're extremely durable. The underlying technology is designed for extremely long wear. It works across many different types of robots right now. Universal robots, the Rethink robots, Baxter, and their new one. Don't forget the company's robot things. Fetch. We've got distributors set up in Japan and in Europe. We're just, like I said, this is the first 100 production units shown around the world. And as the new deep learning technology applied to robots allows them to work in unstructured environments, this is designed to commoditize the gripping aspect of robots so they can start doing something useful for us in our environment. SAKE Robotics, local company, thank you for your time. Appreciate it.
All right, Juan, do you want to go?
Yeah, is there, I don't know.
Huh?
Yeah, I'll go right now.
Okay. So next up is Juan Alvarez of SoundControl.io. And he has an audio streaming platform that makes internet radio and audio streaming extremely convenient and easy for people. Gonna have to bring your laptop over here. If anyone has any other announcements or would like to talk for about a minute or two while we set up, let me know.
Send it to Lieutenant Colonel and his sergeant.
All right, here we go.
Sergeant will be the one that contacts it.
Okay, we've got purple video. Looks like a bad connector or cable somewhere. I don't think we're going to get any better than that right now. I do. I'll tell you what. You can have the next speaker come up and change out laptops. All right, my laptop's next. All right, we're going to bring up our next speaker while he resolves his technical issue. Tori Dyer with Accenture. And when you want to blank out the slides that you want to hide, I will let me know and I'll put a paper plate or something over the camera. Most of them? All right, can you show the first slide and then I'll blank it out so at least we have some idea of who you are? Right now, you're on HDMI. Let me switch the video source back. Hopefully it's not that. There we go.
There we go. Awesome.
John, can we talk next?
Oh, you guys want to talk next? Okay. I'll do you guys a big favor and I'll let you talk next. All right, sorry. Been announced.
Tell you what, let's go through the first 5 or 6 slides.
All right, sorry guys, I've got to cover the video.
5 or 6 slides. We can do the first 5.
Oh, I can do the first 5. Okay, let me know when
After
the.
that, yeah. So, hey everyone. Just for the sake of fun and collaboration, I didn't shorten the deck because there's a lot of information in here with the research, and I kind of wanted you guys to be able to ask questions because I do like collaborative sessions. But as John said, my name is Tori Dyer. I am a researcher at Accenture Technology Labs. I'm in their digital experience department. I do digital workforce. And what we're going to talk about a little bit today is our efforts in using crowdsourcing techniques to facilitate workforce virtualization, or basically allow you to have a liquid workforce. So we've looked at these sizes of tasks, micro tasks, individual tasks, small tasks, and large projects, and we've actually created assets across each of these, right? But on my focus in itself, I did enterprise flash teams, which is a fun way of changing the way that we think about workforces, right? Normally we have a static structure of a hierarchy, right? That's pretty stable. You have your leaders on top, your managers, your CTOs, and all the other fun people, and then you have your underlings on the bottom. But what we're looking at is, what if you had a project, this system of roles, right? Similar to like how emergency management crews works, right? You have a leader, a core team, and then you can quickly onboard and offboard assets as you need, or skills as you need throughout this project. And that's we've made it pretty fluid and very frictionless. And that can be people inside of your organization as well as outside of your organization using public talent marketplaces. So why are we doing this? Well, basically, as we know, we're moving from more old-style waterfall techniques to more agile projects that are very customer-specific, and the requirements keep changing. In fact, sometimes the customer keeps changing. And we need a workforce that can facilitate this, right? And there's some challenges when you're dealing with enterprise, stuff that startups don't necessarily have sometimes, which is the fact that you need to be able to change skills on demand quickly, which is hard for a company because you have to find those skills and you have to find the people with those skills, and then there's onboarding and hiring and all that other fun stuff that you have to do. And then once you're done in finding those skills, then you have to stand them up into a team really quickly, right? And then after that, you have to orchestrate them and make sure they collaborate. Now the thing about using crowdsourcing techniques is that you're not just onboarding people and we're all going to work in an office, it'll be awesome. No, we're dealing with a global market. So your workers are not necessarily on your same time zone or even speak the same language at times. So what did we do? Well, basically, we started looking at the idea of an enterprise flash teams. How can we bring people onto this team really quickly? And our next step in our research was, how do we mix them with internal and external workers? How do we bring crowdsourcing into our company to facilitate other people like Intel and other companies that we work with doing that kind of stuff. And then, we were looking at future things. Can crowds lead teams? And then, of course, as the workforce becomes less human to human and sometimes a little bit more human, how do we facilitate machines into the mix? So I'm going to blaze through this next set of slides quickly. This is our focus. We've been looking at crowdsourcing across these verticals, and this is how Enterprise Flash Teams is looking. And about now, you can probably start.
I'm just going to move the camera so it's not covering the screen. So we just see you now.
So we started with small projects, right? And we've been working with Stanford as we've been doing this for some of the projects. And we've been looking at this, figuring out, what kind of assets can you build with the crowd, right? There are physical assets that you can build. Stanford had this really great example where they actually built a card game using crowdsourced labor with physical cards, physical pieces, and then they decided to throw an app on it. But we also have been looking at, more enterprise kind of things. So we did marketing assets, apps, whether or not the crowds can be able to do things quickly in emergency situations, and then hierarchical. And each one of them has a different focus. So the first project is, of course, can the crowd do enterprise level work? The second one is, can we find niche skills that are hard to find in our organization inside these public marketplaces and bring them onto our teams quickly? The third one is, can our system because we have a technology suite of tools, can our system work and accelerate the time for development for another project owner? And then this project 4 was pretty interesting. We actually said, hey guys, listen, why don't you build your own organization? We got 30 crowd members and we let them self-organize in certain ways to complete a project. And in 2.5 weeks, we got 30,000 lines of code done. And they were across all geographies. It was actually a pretty fun project. So, as you said, goals, what can it do? And these are the projects as we go through. I'm going to kind of speed through this a little bit. And these were some of the tool sets we have. Some of them are very familiar to you. And this is what we initially started with. And I'm just going to go through what we found. You get the guys on the crowd, very valuable. They can do a lot of good work. But of course, we looked at lowering the cost of transaction for the project coordinator. And these are the costs. And then we added these. Now, what this is basically we said, okay, we need better ways of coordinating because, it takes a lot of time for the project coordinator to, do a lot of tasks. And as the project changes over time, we need better living documents. We need more collaborative workspaces. We need tools that actually allow for this live collaboration to happen. Because some of the cool things that we found was that, if you have a problem, the crowd can actually solve it faster than the stakeholders can think of new issues or even vet the issues itself. And as requirements change within a project, which always happens, some of that information sometimes doesn't get across to the rest of the team. So we tried it with these two projects. One is a business development video that we did, and the other one is the enterprise web app. And it seemed to work really well to the point where we were able to drop the stakeholders, the project coordinators' involvement down to about 18%. Then we said, okay, great, we have this. What can we do? We understand the challenges, we understand the technology. So we did projects 8 through 5 through 8, and then we started working on a new set of things with mixing internal and external resources together, right? And some of the things we found out, and this is our technology suite, we started making sure that the technology tools actually started working together, right? Slack is pretty cool because it's not just a person-to-person communications platform, it's also person to app, app to app, and if you know how to work those integrations right, you can actually do some pretty cool things. Cloud 9, they also have a really amazing collaboration tool for, doing coding. And I'm going to kind of go through this a little bit because I'm almost out of time. But at the end of the day, I was able to onboard a person from hello to coding in 30 minutes. And I was able to find people in less than a day as another fresh project coordinator was able to do. Right? And this was the difference between what we had and what in terms of hybrid teams and what our more traditional ways are. So just remember, we're doing crowdsourcing across internal and external markets. So that means that internally, you are also able to find people in less time than it normally takes in your traditional markets. And then you're able to answer the problems in your team in terms of your teams and your projects, in terms of skill gaps, or even bandwidth gaps, which in some cases we had. I've had to leave a project to say you're a leader and hire on a new set of developers, and it takes like, what, 5 hours sometimes. So in short, right now we're also looking at methodologies in coaching and training. So how do you accelerate the time towards hard platforms and niche technologies? So like AWS, a lot of you probably have worked with it. It's not, it's something that you definitely need to have experience with, right? And if you have if you as your team are going in and trying to learn this, okay, fine, you can burn 6 weeks of development time doing